Okay, so we outran the giant boulder, we battled the fearsome monster, and now, Lucy, we finally found it. The Scroll of Pythagoras.
Isn't it beautiful, Will? The legend says that Pythagoras' theorem will be revealed to the person standing closest to the scroll.
Okay, well, I'm going to stand at the corner of this pit, but I don't know how you're going to get any closer without falling in.
Well, I have a feeling that if I stand here, the secret should appear to me. Aha! There they are. A squared plus b squared equals c squared.
But I don't understand. You're not standing any closer to it than I am.
It doesn't look like it, but you're actually standing about 40% further away than I am. And to explain how, we're going to need this beautiful equation. So here's the scroll, surrounded by the square pit. Will is standing at the corner of the pit, and I'm standing at the midpoint of one of its edges.
Okay, but I thought squares were symmetrical. I still don't understand how you're standing any closer.
Well, why don't we draw it out? This diagonal line is the distance between Will and the scroll, and this straight line is the distance between me and the scroll. If we line them up, we can see that my line is shorter, so I'm standing closer.
Hey, the legend was right. You saw the equation because you were standing closer after all. Hang on, isn't that a right-angled triangle?
Yes, it is.
Okay, but what is a squared plus b squared equals c squared then?
Well, let's label the sides of this right-angled triangle. I'm going to call this short side A, this other short side B, and this longer side C. C has actually got a lovely name, the hypotenuse.
That's a brilliant name.
The hypotenuse is always the side opposite the right angle.
Okay, so what does squared mean?
When we say A squared, we literally mean making a square out of A. The same is true for B squared, C squared, or anything squared. To turn A, B, and C into squares, I'm going to draw out some more right-angled triangles. Like that. You can see that all of these right-angled triangles are exactly the same size. We can rearrange them to turn A, B, and C into squares. There we go. Can you see what this shows?
So a squared is 2 triangles, and so is b squared. But c squared is 4 triangles. 2 plus 2 equals 4, which means that a squared plus b squared equals c squared. I get it now. That's so cool.
Now that we know what a squared plus b squared equals c squared means, we can use the equation to work out the distance between Will and the scroll.
The legend says that the scroll is surrounded by a 4 metre by 4 metre pit.
Okay, so if the sides of the square pit are 4 metres and the scroll is in the middle of the pit, we can halve that side length to find out how far away I am from the scroll. 4 metres divided by 2 is 2 metres, so I'm standing 2 metres away from the scroll. If we bring our right-angled triangle back, we can see that we now know the value of A, so let's swap A with 2 metres. We can also see that because the pit is a square, A and B happen to be the same length, so we can swap B with 2 metres as well.
Okay, so we know the values of A and B. How do we find out the value of C?
Well, this is where our old friend Pythagoras comes in. We know that Pythagoras' theorem states that a squared plus b squared equals c squared, and we now know that a and b are both 2. So let's rewrite the equation. C squared is equal to 2 squared plus 2 squared. When we square a number, we multiply it by itself.
That's easy enough. 2 times 2 equals 4, which means that a squared and b squared are both 4?
Yes, that's right. Now we know that c squared equals 4 plus 4, which is 8.
Okay, so we know that c squared equals 8. But how do we know what c is? How do we unsquare 8?
Well, the opposite of squaring a number is called the square root. What number multiplied by itself makes 8? I know that the square root of 4 is 2 because 2 times 2 is 4. And the square root of 9 is 3 because 3 times 3 is equal to 9. So I reckon the square root of 8 will be somewhere in between 2 and 3, which means it'll be a decimal. We're going to need our calculators for this. We need to press the square root button, the number 8, then the equals button, and there we go. 2.82847271247. So that means Will is standing around 2.8 metres away. Just as I suspected, that's about 40% further away than I am. The legend never lies.
Okay, so I'm going to quickly remind myself. To find the length of the long side of a right-angled triangle, we can use Pythagoras' theorem, which tells us that a squared plus b squared equals c squared. A and b are the two shorter sides of the triangle, and c is the hypotenuse, or the longest side of the triangle, which is always opposite the right angle.
Did you know that you can use Pythagoras' theorem to find out the lengths of the shorter sides as well?
Oh wow, that's so useful!
The amazing thing about Pythagoras' theorem is that it can be used on any right-angled triangle, even if A and B are different lengths. Here's another right-angled triangle. Just like before, I'm going to label its sides A, B and C. Remember that C is always the hypotenuse, or the longer side, opposite the right angle. Let's say that A is equal to 3 and B is equal to 4.
So we do 3 squared, or 3 times 3, which is 9. Then we do 4 squared, or 4 times 4, which is 16.
That's right. Then we add 9 and 16 together, which is 25. So that means that c squared is equal to 25. To find out the value of c, we do the square root of 25. You might be able to do this one in your head, but if not, grab your calculator and press the square root button, then type 25, then press the equals button. And there we are. C is equal to 5. That's a nice, neat number.
So Pythagoras' theorem works on any right-angled triangle. This Pythagoras guy must have been a genius.
Did you know that he wasn't actually the first person to discover the theorem? It's very likely that the Babylonians and many others were using it before Pythagoras, even though it's named after him.
I suppose mystery Babylonian person's theorem doesn't quite have the same ring to it.
Okay, let's play a game. The legend says that to get to the exit of the cave, we need to walk up the longest slope. There are 3 slopes to choose from, and I want you to work out which one is the longest. Here's the first one. The legend also says that for slope number 1, A is equal to 5 metres and B is equal to 12 metres. What is C equal to? If you want, you can pause the video and do it all by yourself, or keep watching to hear Will's answers.
Okay, so we know that c squared equals a squared plus b squared, but we also know that a is 5 and b is 12. So c squared equals 5 squared plus 12 squared. 5 squared, or 5 times 5, is 25. 12 squared, or 12 times 12, is 144. That means that c squared equals 25 plus 144. So c squared equals 169. To find out what c is, I need to do the square root of 169. So on my calculator, I'm going to press the square root button, type 169, and then press the equals button, which gives me 13. That means slope number 1 is 13 metres long.
Okay, great. Here's the next one. The legend says that for slope number 2, A is equal to 7 metres and B is equal to 6 metres. What is C equal to?
Okay, so we know that A is 7 and B is 6. So c squared equals 7 squared plus 6 squared. 7 squared, or 7 times 7, is 49. 6 squared, or 6 times 6, is 36. That means that c squared equals 49 plus 36. So c squared equals 85. To find out what c is, I need to do the square root of 85. So on my calculator, I'm going to press the square root button, type 85, and then press the equals button, which gives me 9.2195444,573. That means slope number 2 is around 9.2 metres long.
Excellent! Here's the last one. The legend says that for slope number 3, A is equal to 4 metres and B is equal to 15 metres. What is C equal to?
Okay, so we know that A is 4 and B is 15. So c squared equals 4 squared plus 15 squared. 4 squared, or 4 times 4, is 16. 15 squared, or 15 times 15 is... I'm going to need to use my calculator. 15 times 15 is 225. That means that c squared equals 16 plus 225. So c squared equals 241. To find out what c is, I need to do the square root of 241. So on my calculator, I'm going to press the square root button, type 241, and then press the equals button, which gives me 15.5241746963. So slope number 3 is around 15.5 metres long.
Amazing! So slope number 1 is 13 metres long, slope number 2 is around 9.2 metres long, and slope number 3 is about 15.5 metres long.
Slope number 3 is the longest. We better get out of here! Okay, so I'm going to remind myself one more time. To find a missing length from a right angled triangle, we can use Pythagoras' theorem, which tells us that a squared plus b squared equals c squared. A and b are the two shorter sides of the triangle, and c is the hypotenuse, or the longest side of the triangle, which is always opposite the right angle.
Yep, looks like you've got it now. Pythagoras' theorem is so useful because you can find right angled triangles everywhere. Every single square and rectangle can be turned into right angled triangles too.
Wow, I never realised how interesting triangles were. Thanks, Lucy. If you want to keep practicing, download the worksheet in the video description. If you could only eat food that's roughly in the shape of a triangle, what would you eat? Tell me in the comments below. If you like this video, make sure to give it a thumbs up. Subscribe to learn more science, English and maths with Will, and let me know what you want to learn next by commenting below or emailing info@learnwithwill.co.uk.